So in this video, we're going to look at how we can request raster data from ClimateSERV using the ClimateSERVpy API. So just as we did last time, we're going to start by installing the ClimateSERV package, and we're also going to install this raster IO package. Oh, and I forgot, before we begin, we want to click File and save a copy in Drive, because that will allow you to create your own cells when you're working with this notebook. So we're going to click File at the top and then save a copy in Drive, and then we can close out of the original and run all of these cells in here. So again, we're going to install ClimateSERV as well as this raster IO package, which will allow us to visualize raster data in this notebook. And we're also going to import some other packages that will help us to extract files from zip folders, because that's how we will end up downloading our data from ClimateSERV. So now that those have finished running, we will go ahead and mount our Google Drive. If you need a refresher on what this does, you can see the previous video on obtaining tabular data from ClimateSERV. And then just as we did before, we're going to choose our My Drive directory, and then we're going to make a directory called ClimateSERV data to store the data that we want to get from ClimateSERV. And then we'll actually choose that directory, and then again, just as we did in the last video, we'll print working directory, and as we can see, we are in the ClimateSERV data folder within My Drive. And if I go to My Drive and refresh, I can see there's a folder called ClimateSERV data. And just like before, it's empty right now, but we're going to request some data to that folder. So again, I can use the ls command and see that there's nothing in the folder, so let's go ahead and change that. So just like we did last time, we're going to specify these different arguments: the geometry, the data set, the operation type, the start date, the end date, and then the ensemble and variable if we're using that NMME forecast data, and finally an out file. Since we're not requesting the data, in this case we're requesting the chirps precipitation data, we can just leave the ensemble and variable as blank. As you can see, we're just requesting a month of data. This data set has a daily temporal resolution, so we're going to get a acquisition for each day in the month of August in 2015. And our operation type is set to download. So as you recall before, when we were requesting tabular data, this time we're going to specify the operation as download, which will give us the raw data from ClimateSERV. And whenever you specify your operation type as download, you're usually going to want to put a file extension of .zip. And so what the what the download argument to operation will do is tell ClimateSERV that you want .tiff files, which stands for tagged image files. And so when we specify the operation type as download, we want to end the out file with an extension of .zip. And the .zip will just be a folder containing these TIF files within them. So I'll go ahead and run that, and this is just a random geometry I've specified here. And let's submit the request to ClimateSERV. So as we can see, it's 98% done, and it's already finished. And it is downloading the file currently to chirpsdata.zip. So now what I'm going to do is make a directory. So this is going to make a folder within the folder that we're working in right now called unzipped files. So I'll go ahead and run that, and then we'll just do ls to see that we were able to make that directory. So now we can see our previously empty directory now has the chirps data in a zip folder, and it has this other folder called unzipped files. And if we go back to Google Drive, we can see that now we can see the same thing there. So now I could just extract the data to that file, but I can do the same thing in my script here. So I'll go ahead and do that, and then I will go ahead and choose this unzipped files folder as my directory using the cd function. And doing that, after we click ls, we can see that we have, just as I mentioned before, an acquisition for each day. So a TIFF file for each day of this chirps data for the specified region of interest. And going into the actual folder in Google Drive, we can see the same thing. So ClimateSERV will download this data in year, month, day format. So this image corresponds to the chirps data for this region of interest on August 1st of 2015. So really quickly, let's just visualize that image. So this is where I'm using that Raster IO package to just create a really simple visualization of this image. So let's zoom out a bit to get a better look at it. But in this color palette that I've specified, warmer colors like red and orange are going to specify lower precipitation values, whereas cooler colors like blue or that light blue are going to represent more precipitation. So the darker the blue, the more precipitation there is. And I've specified some visualization parameters. So dark red is 0 and dark blue is set to 30 here. And of course, you're going to want to reference that ClimateSERV dataset encyclopedia to determine the units that your dataset is in whenever you're visualizing the data you downloaded from ClimateSERV. So I'm going to stop the visualization exercise here, but of course we can make this more complicated if we wish to. We could take all of the data here and make an animation. We could work with this data in QGIS, but I hope I was able to show in this video that instead of working with the files with a user interface and moving them around on your Google Drive or on your personal computer, the ClimateSERVpy API is really good if you want to automate that process within a Python script, right? We can move these files around and manipulate these files all within a Python script. And so that really allows you to automate these workflows with ClimateSERV. So for the purposes of this video, we're going to stop here. And now it's your turn to take everything you've learned in this course and apply it to a personal project. So you can use the ClimateSERV user interface if you want. You can use the application programming interface. So whatever way you prefer to work with the data in ClimateSERV, you can go ahead and use that method to take the data and answer a scientific question in your region of interest. So that's it for this video, and thank you for listening. ClimateSERV was developed by Sevire's Science Coordination Office, specifically by Ashutosh LeMay, Brent Roberts, Eric Anderson, Billy Ashmall, Githika Tundapu, Francisco Delgado, Roberto Fontanarosa, Lance Gilliland, and Alex Goberna. The curriculum materials were organized by Sevire's Science Coordination Office. Individual modules were created by myself, Mickey Maganini, and Billy Ashmall. Crucial insight regarding the creation of the curriculum materials was provided by Dr. Roshanak Darvishzada. Review of the material was conducted by Sevire's Science Coordination Office, specifically Brent Roberts, Meryl Kruskopf, Ashutosh LeMay, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthin, Natalia Bermudez, Stephanie Melick, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Emil Sherrington, Francisco Delgado, Biplav Bhandari, and Amanda Markert. Review of the materials was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geo-information Science and Earth Observation at the University of Twente. The course and banner images were created by Gianluca Ambrosi of ITC.